My name is Ibrahim Ali. This is my project defense for my individual project. My individual project topic is feasibility study into using robotic methods for aerospace manufacturing and assembly processes. In this slide, you can see the contents that will be covered in this presentation. It includes the introduction to the project, relevant research, the design choices that I made, environmental impact of the project, and future development on robotic methods for manufacturing. Moving on to the next slide, evolution of robots has changed enormously towards the end of the 20th century. The development of automation birthed after World War II. In the late 1960s, the incentive of robot automation was driven by high labor cost. Companies aimed for high efficiency at a lower cost and saving time. After seeing that using robotic methods in the automotive industry was successful, aerospace companies started to incorporate the same methods to assist human workers in physical demanding tasks such as painting and drilling. This project aims to delve into the possibility of incorporating robotic methods in aerospace companies to ensure high efficiency in manufacturing and assembly. Also, it will oversee the use of robotics in individual manufacturing of aircraft structures and assisting human labor. The overarching project aim is research, design, and analysis of robotic methods into aerospace manufacturing and assembly processes. The project objectives are researching on current manufacturing technique used in aerospace industry. The second one is designing CAD models of the robot jig and the end effector on CATIA. And the third one is carrying out analysis and justification on the design choices. In this slide, I'm going to talk about the current approaches that are currently used in the other industries. Robotic technology has advanced tremendously, primarily due to the automotive industry adopting robotic manufacturing disciplines. Robots are used on tasks that are performed in harmful conditions. This is to avoid imposing health risk and injuries to human workers. In the aerospace, drilling and riveting is done by human workers. This causes physical stress on their shoulders, joints, and may even cause permanent damage. My personal aim for this project is to assist human workers in manufacturing and not replacing them. Here you can see the comparison of humans against robots. The approximate efficiency for robotic application versus manual application was compared. As you can see in diagram A, the efficiency of manual machine tending was about 40 to 60%, and for robotic machine tending was about 90%. However, detailed values are dependent on the characteristics of the real workstation as seen on the images. The most decisive factor for industry is the economic cost of production. Implementations of robotic workstations require very high investment cost. It can bring greater work efficiency and savings in labor cost, especially if one robot can replace several human workers. Moving on, there are three robotic applications that were considered. First, applying sealant, second, drilling and riveting, and third, painting. They were broken down where key decision was made by choosing drilling as the preferred application to work with. In this slide, you can see the robot anatomy with its specifications. This is an articulated robot which has 6 degrees of freedom. It allows the robot to move in XYZ plane as well as positioning itself using roll, pitch, and yaw movements. The payload on the robotic wrist is 225 kg. It has a maximum range of 3.4 meters where it's able to access all the fuselage and drill holes in it. It is remotely controlled within the compound, and the application of it is drilling and countersinking holes. As you can see on the table on the right, it shows the robotic motion speed and the robotic motion range. In this slide, you can see the final design concepts that were made. On the top right, you can see the hydraulic jig that is used to lift the fuselage with an extension of 1 meter in order for the robot to have accessibility. The robot is mounted on the fixed jig as seen on the image. At the bottom, you can see the drilling end effector and the robot arm. Moving on to the next slide, I will be explaining the method of operation. There are two robots that are mounted on the fixed jig moving up and down along the fuselage frame and are located on each side of the floorboard as seen on the diagram. The hydraulic jig holds the aircraft fuselage and acts as a positioning gauge as the robot arm fully extends. Once the number of holes in the fuselage has been completed, the hydraulic jig moves to the next step of the assembly line where the fuselage goes for inspection as seen in the production flow image. This design mechanism is just one of the new manufacturing assembly schemes of A320 production. The system includes robots that help build the forward and aft section of the aircraft fuselage. The pairs of robots move in unison motion around the structure, drilling the holes of the fuselage. Within the system, it is designed to be highly flexible because everything is fundamentally easily accessible. The drilling operation is controlled by mechanics who sit behind a computer and locate the section of fuselage to be drilled. In any design, there's always room for improvement. In my case, I believe by adding cameras onto the end effector, it will enhance the vision systems of the robot wrist and increase accuracy. Also, however, installing higher capacity batteries to ensure robot can operate for a longer period. Moving on, in any working environment, considering the environmental impact is very crucial. Robots in the workplace promote a greener environment. To be green means energy efficiency and environmental friendly manufacturing process. By replacing manufacturing floor workers with robots, the environment inside of the factory can change. Since there are no longer humans working, they do not have lights on or off. By reducing energy involving air conditioning, heat and lighting the facility, a greener workplace will be promoted. In this slide, I'm going to cover the future development of using robotic methods. Soon we can see humans working verbally alongside robots with the aid of artificial intelligence. Companies around the world are increasing their use of industrial robots. Within 5 years, the global operational stock rose by 65% to 2.4 million units from 2013 to 2018, as seen on the image above. Finally, I'm covering the impact of society that has been caused by robotic manufacturing and its significance as covered in the slides above. First, employment in the automotive industry alone has increased by 22% from 800,000 to more than 1 million jobs from 2013 to 2018, as mentioned in the previous slide. Second of all, it creates more opportunities and jobs in our society in reference to the previously point mentioned. Third, using robotic method has simplified the time period of aircraft manufacturing from years now to doing it in months only. Thank you so much.